Welcome to MyProjectBazaar.com. Now we are going to discuss about the product EEG signal classification using PCA, ICA, DWT and support vector machines. Now we are going to discuss about the abstract for the process. This processing and the analysis of EEG within a proposed framework has been carried out with DWT for the decomposition of the signal into an frequency subbands, and to set the statistical features was extracted from the subbands to represent the distributions of the wavelet coefficients. Reduction of the dimension of the data is done with the help of the principal component analysis method and then the independent component analysis method. Hence, this will optimize the features present in the signals. Then these features were used as an input to the neural network for classification of the data as the normal or otherwise it will be the abnormal. Hence, this will provide the efficient classification system for this process. After that, the performance of the classification will be estimated due to the different methods of the presented and then compared shown with the excellence of classification process. Hence, the performance parameters was improved and then it will prove the proposed method is more efficient than the other existing systems. Now we are going to discuss about the flow diagram for the process. This is the overall working flow for the process. At first, the input signal is taken from the dataset. The dataset is the folder which consists of the several signals which consist both the normal and abnormal signals. After getting any one signal from the dataset, the pre-processing was carried out. In this pre-processing step, there are two types of filtering is used. First one is the bandpass filtering and then the second one is the IIR filtering. By using these two filters, the other unwanted signals will be reduced and then the recovered signal regions will be extracted. After extracting these recovered signal peaks, the feature extraction will be carried out. In this feature extraction, we can generate the test feature with the help of the three parameters like ICA, PCA and DWT. By using these three parameters as well as these three algorithms, we can able to extract the test feature from the signal. After extracting the test feature, the feature matching will be done. In this feature matching, we can give the three things as an input. First one is the test feature, then train feature, then labeled feature. The test feature is represented as the feature of the input signal getting from the dataset. The train feature is represented as the features of the whole dataset signals. The label is represented as the category. Whether the input have the two category means like an normal or abnormal means the labels will be predicted for both two categories. After the feature matching, hence the performance will be evaluated. Hence in the feature matching, the multi-SVM provides the match feature classification stability and then the performance will be evaluated by using the three parameters like accuracy, sensitivity and specificity. By these three parameters, we can able to justify our process is efficient or not. Now we are going to discuss about the initial running procedure for the process. At first, open the MATLAB 2015B and change the current directory. If you want to execute the code means just right click in the main_GUI.yam and select the option run. Now the initial GUI was open. In that GUI you can see the several axes, several tables and then the several text region for the display purpose. At first, if you want to run the GUI means select file to input signal. After selection of the input signal, just open the signal from the dataset. Now the selected input signal is plotted in the axis 1 with the title input signal. After getting the input signal from the dataset, the pre-processing was carried out. First of all, the band pass filter is applied for the first level of pre-processing. Now the filtered signal is shown in the axis 2 with the title filtered signal. After applying the band pass filtering, the IIR filtering is applied. After applying the IIR filtering, it will take some time and then it will display as a result. Now the IIR filtered signal values will be plotted as a graph format in this figure window. After the IIR filter, the feature extraction will be done by using the ICA method. After applying the ICA feature will be shown in the table 1. After the ICA, the PCA is applied for the feature extraction. Now the PCA values are shown in the table 2. After the PCA, the DWT was applied. Hence, the DWT consists of the both table values as well as the figures. Now this figure 2 represents the wavelet signals. Now the DWT wavelet will be applied and then the wavelet signal will be shown like this. After the feature extraction, the feature classification was done. In this feature classification, whether the input signal is the normal signal or abnormal signal, after the classification of these two categories, that result will be shown like this. After the feature, the accuracy, sensitivity and specificity will be calculated and then those corresponding values will be tabulated as well as those values will be shown here like this. If the accuracy is 98% means like this it will be displayed, then the sensitivity and the specificity will be displayed like this. Thanks for watching this video.